let's see first of all what the question is saying. I was saying this thing. So in the beginning there is a box, or we could say there is a cube, something like this, let's say this, then something like this. Initial stage, the cube is like this. But now what is happening, there is a tangential force, and that is of 8 kilonewton, which is acting on it. And because of that, now there is a change in a little bit, right? There is a strain a little bit. So there will be, it will be tilted up a little bit. We have studied this thing, that it will be tilted up like this, let's say. Okay, so where is the force acting? First of all, there is a parallel force acting to the surface, and that will be F parallel. The side is given to you as it is a cube, so every side will be equal for sure. So let's say the side is given to you, that is 4 centimeter, which I have written over here. Next, what? The displacement. See, this is the change. We know that if this is the change, and that is also given, the displacement is also given, that is of 0.1 mm. So we can also say that that change, that is we represent with x, is also given as 0.1 mm. What else is given to you? The force is also given, the parallel force is also given, and which is 8 kilo Newton. Very, very simple question. See, we just have to put it in the formula now. So what is the formula we will be using? First of all, we cannot use that formula which we were using initially, as that was the Young's modulus thing, but instead we will be using the Shear modulus over here. So if we are going to use that Shear modulus, so we will use S is equals to force, same things, but in this, instead of force upon area, but instead of writing del L, we can write X upon H. So S will be equals to the parallel force, that is 8, right? And as you are converting it into the dynes, so you can write, because it is in centimeters, so we will go with the CGS units. So it should be 10 to the power 3 of the kilo. And when you will convert 1 Newton into the dyne, it will be 10 to power 5. Okay. Now what? Then we have to place the side, or we could say height. What is this height? This is H, which is given. So we can place it H. Then what is the area? You can simply find the area with the side is given. How will you find for the cube? It will be simply side square. So if you will do the side square, it will be 4 multiplied by 4. And what about the this change? This change is 0.1 mm. Now, though we are taking it in the CGS unit, but still we have to convert this mm into the CGS unit, that is into the centimeter. So you just have to divide it with 10. In that case, it will be 0.01. You are converting mm into centimeter. If you are converting centimeter into mm, then multiply by 10. Converting mm into centimeter, divide by 10. Now, when you will solve it, you will see 1 4 can be cancelled out, so it will be 2 on the tops, and then it will be 1 by 2, and then it should be 4 4 16. So it should be, height is also there, so height you can place the 4. I forget to place that. Now when you will solve it, 1 4 goes over here, this 4 something like this, and this turns out to be 2. Then this will give you 2 zeros on the top, that will be 100. So 100, that is 2 zeros plus 5 plus 8 gives us to be 2, multiply by 8 plus 2 is 10. So it's 10 dyne per, not meter square this time, per centimeter square, and this will be the unit for shear modulus. This is how we do this question.